when B is very close to A, we can then say the velocity during that very small interval can be called the velocity at A, and that will be defined by the tangent drawn at that point. So velocity at the point A is called the instantaneous velocity. So let me come again here. You can see delta x divided by delta t. Can you tell me what quantity that delta x divided by delta t defines? If you come in here, now if this is my delta t, now delta x divided by delta t is the rate of change of position. We actually call it the slope of this line. You see, the average velocity during this interval is the slope of that line. The average velocity during this interval is the slope of that line. Average velocity during that interval is the slope of this line. So what are we doing? We are making the interval shorter and shorter. The average velocity during this interval is the slope of this line. And finally, when you come to point A, we don't have a secant line anymore. You can see all these are secant lines. At point A, we have a tangent line. And therefore, the instantaneous velocity at point A is the slope of that tangent line. Whereas average velocity is the slope of the secant line. The instantaneous velocity is the slope of the tangent line. And it is a measure of delta x divided by delta t when delta t approaches 0. When delta t approaches 0, point B almost comes and joins with point A. And the velocity at point A then is the slope of the tangent line. I hope you understand that concept. It's very important to understand that concept. Alright, let's move on. Therefore, instantaneous velocity, V instantaneous, is defined like this. It is the limiting value of delta x divided by delta t. You understand the meaning of limiting value. As delta t is made smaller and smaller and smaller, the limiting value of delta x divided by delta t is called the instantaneous velocity at that point. And therefore, it is the slope of the tangent line at that point. And those who understand calculus will call it the derivative of the position function. If you are not doing calculus, you don't need to worry about it. But understand it as the velocity at A, the instantaneous velocity at A, is the slope of the tangent line at that point. Okay, I think I have an animation showing that concept. Here, you can see delta t gets closer and closer to 0, and the secant line becomes a tangent line. Average velocity in an interval becomes instantaneous velocity at a point. You see that? The slope of the secant line is a measure of the average velocity. And tell me, when does the average velocity become the instantaneous velocity? When the time interval is almost 0. When point A and point B are almost one on top of the other. You understand the difference between instantaneous velocity and average velocity. It is very important to understand that concept. Therefore, if you draw a graph of displacement against time, in other words, position of the object, draw a graph of position on the y-axis and time on the x-axis, then the velocity, if the velocity is a constant, you will get the graph a straight line, and the slope of that graph will give you the constant velocity. You see, if the velocity remains a constant, then only the line will be a straight line. So displacement against time will be a straight line if the velocity remains a constant, and the slope of the displacement against time graph will be a measure of the velocity. On the other hand, if the graph of displacement against time is a curve, then the velocity changes from point to point. Here you have the velocity changes from point to point, and watch this carefully. If this is my point A and this is my point B, then if I draw that straight line there, this will be called a secant line. The average velocity between these 2 points will be the slope of the secant line. And in order to define the instantaneous velocity, what do? Bring points A and B closer and closer so that this delta t is very close to 0. And then the limiting value of delta x divided by delta t will be then the slope of the secant line, the slope of the tangent line at that point. You see that? Instantaneous velocity is the slope of the tangent line. Now understand the difference between average velocity and instantaneous velocity. Okay, I think we can now use these concepts to solve problems. Before we start solving problems, I would like to demonstrate to you the difference between average velocity and instantaneous velocity. What I'm going to do is I'm going to run this car from an initial position given by this photo gate to the final position given by this photo gate. Now, when the car, you can see I have placed a little splinter here. When the car moves through the photo gate, it will disturb or block a beam of light that will then start this clock. And when the car reaches the second gate, this clock will stop. In other words, it will measure delta t, the change in time. And we know delta x, and if you know delta x and delta t, we can find the average velocity. Is that right? Now, I have put delta x as 60 centimeter, that is 0.6 meter, and I'm going to run this car. What I'm going to do is I'm going to use a car, well, I'm going to launch the car with this. This is like a gun. I can shoot the gun in motion. I'm going to load it and I'm going to shoot the car, all right? Okay, watch what happens when I shoot the car. The car is, well, let me see if I can shoot this car properly to behave, all right? I may not get it go in the straight path, but then I will have to repeat it, all right? I'm going to shoot the car now. There you are. So, well, apparently the clock didn't start. Is that right? Well, I'm going to make a third attempt and see if the clock responds. All right, now what does that time interval tell you? 0.0169 is the instantaneous rate of change. In other words, this is my delta x that is very small, and this is my delta t, which is very close to 0. So the instantaneous velocity will be this time delta x divided by delta t, where delta x is the width of the splint and delta t is this. Is that right? So you can see we brought the interval closer and closer, making delta t very, very small. And now we made that delta t so small that during that delta t, the displacement is only the width of the splint. That means A and B are almost on top of each other. This is the meaning. Limit delta t approaches 0, delta x over delta t is the instantaneous velocity of the car. Now, let's see if I move the car in there with the splinter, we can measure the instantaneous velocity. And there you go. Now, the width of this is about 0.5 centimeter and the time taken is 0.0107 second. So what is the instantaneous velocity here? I'm going to leave it for you to calculate. Well, I hope you got some idea of the difference between average velocity and instantaneous velocity. A simple problem. Well, the problem goes like this. The position of an object is given by the function x of t equal to negative 4.9 t squared plus 15. What is the velocity of the object 5 seconds from the start? At the instant when the time is 5 seconds, what is the velocity? We are looking for instantaneous velocity. Now, what is the definition of instantaneous velocity? Instantaneous velocity is the limit when delta t approaches 0 of delta x divided by delta t. And this is what we call the derivative of the position function with respect to time. Is that right? So, velocity, instantaneous velocity is the derivative of the position function with respect to time. We are given the position function and we need to find the instantaneous velocity when time is 5 seconds. So what all you need to do is find the derivative of the position function, and in that derivative set t equal to 5 seconds. Alright, let's do that. Alright. Instantaneous velocity is the derivative of the position function. What is the derivative of this function? X of t is negative 4.9 t squared plus 15. The derivative of this will be dx by dt, use the power rule, negative 9.8 t plus 0, or the velocity at any time is negative 9.8 t. And we want to find the velocity at t equal to 5 seconds. So v of 5, velocity at t equal to 5 is negative 9.8 times 5. That is negative 49 meter per second. Now you can see the instantaneous velocity contains two information. What are the two information? The rate at which the position changes is 49 meter per second. Every second its position changes by 49 meters. Also it tells you the position changes in the negative x direction. So it tells us that the object is moving to the left. Moving to the left. That is the negative sign. the two information. Well,